welcome to another heat transfer question. We have a person that has his arms, and we have a temperature and a speed. And so that's the temperature of the air, and we have the temperature of the arm, and we're going to treat it like a cylinder. It's close enough to a cylinder, so we can treat it like a cylinder. And then what we can do is we can look at the properties of the air at the film temperature. So the film temperature is 54 plus 86 by 2. And then we're going to look at the properties there. So all of these numbers would likely be given to you. And then the first step is always calculate the Reynolds number. So that's velocity times the diameter over the kinematic viscosity. So we have the kinematic viscosity right there, 1.643 times 10 to the negative 4. Perfect. Now we need the velocity and the diameter. 2 foot long, 3 inch diameter. So all of these are in feet. So we need to make all of the units consistent. So 3 inch divided by 12, that's how many feet? And then we need velocity. So that's 20 miles per hour. So 20 times, then there is 50 to 80 feet in a mile. So to get from miles to feet, then this is per hour. So we need to convert to seconds. So divide by 3600. We type all of this into the calculator. We get 4.463 times 10 to the 4th. Okay. Next up, generally the Newton number. For cylinders, the formula is 0.3 plus 0.62 times the Reynolds number, so 0.5, times the Prandtl number to the 1/3, 1 plus 0.4 over Prandtl number. I always write RR for some reason. PR to the 2/3. This entire denominator is to the 1/4. This entire bracket is 1 plus the Reynolds number over 282,000. Then we have this fraction, this is the 5/8, and this is to the 4/5. So we typed all of these numbers into our calculator, substituting in the Prandtl number and the Reynolds number that we were given or we calculated respectively. We get 129.6. Be very careful with these numbers when you substitute them. The final goal is to determine the rate of heat loss, so that's Q dot. So that means we need H. So H is K over D times the Newton number. That's how we define the Newton number. So we were given K, that's up here, 0.01457 times the Newton number, 129.6, times the diameter, we said was 3 inches, but we needed that to be in feet, so 12. When you're working with the imperial system, be very careful with inches and feet and miles and BTUs, just because the conversions aren't perfectly clean. So because this is in BTU per hour feet, the K is, our answer will be in BTU per hour feet, all that mess. So 7.553 BTU per hour times feet squared, degree Fahrenheit. Okay, now we need Q dot. Q dot is HATS minus T infinity. That is Q dot. Well, we don't have A. We have HT. We just need A. So area is the surface area of where the convection is taking place. So we don't really worry about the ends of the pipe, we just worry about the pipe area. So pi dl is that area, because the circumference of a circle is pi d, and then we unwrap it to go along L. So that's A. Let me say Ts minus T infinity. So 7.553. These are terrible, but it's fine. Times pi times G was 3 by 12. L, what did we say L was? L, 2 foot long. That's already in feet. Phenomenal. Less unit conversions. I just forgot. I think it was 2. And then Ts minus T infinity. So Ts was the temperature of the skin, 86, minus the temperature of the air was 54. So we type all of this into our calculator. We get 380. What's the unit of Q dot? Well, it's a energy transfer rate, so BTU, because we're in English. And then time. The time we have for everything else is in hours, or that is our unit from H. So 380 BTUs per hour. And that is how you do this question.